So you're going to start with your half sheet of paper on the back, okay? And when you tape this in, you're going to tape it down flat like this so you won't even be able to see what you did on the back. So if it isn't perfect or whatever, it's not going to matter. So I want you to draw this, and don't draw it tiny. You need to draw it kind of big on there. If I was thinking ahead of time, I would have copied it on the back, but I didn't think about this until it was too late. And so basically just do this so it's kind of the first quadrant. So you want some room so you can write on it. And then I want you to get stuff out of your brain because it's been a minute since we've talked about this as a group. And once you just get that thrown in there, it doesn't have to be beautiful. Just know that it means the first quadrant. And then I want you to go in here and write in your angle measures in radians. And don't forget 0. On one of those quizzes, there was a lot of people who kind of left off 0. 0 is still important. Okay. So how'd we do? We're experts at those by now? Yes? All right, now I want you to go back in and put your ordered pairs for the first quadrant. When you're done, check yourself with me, but try not to just copy down what I have. And for me, when I'm like if I'm going to write out the whole first quadrant like we are, then usually when I'm writing, when I get to like here, I'm thinking about it spatially. Like I'm going to go to the right 1/2 and up square root of 3/2, and I know that I'm going to go to the right less, that type of thing. But if I'm not necessarily writing it all out and I'm thinking about it individually, then I'm more thinking about the hand trick just because I don't want to think about the whole thing. But everybody, you know, your brains work differently. And so I can tell some of you, like I can see your little eyes move and you're thinking around the circle, whatever works for you, but don't forget the hand trick exists, okay? If you don't want to use it and you got another way, that's fine. But if you're struggling and you're not sure, then you need to use your hand trick, okay? Are we good on those? Yes? All right, so now on the outside of your ordered pairs, put your tangent values. Let me grab my water. Turn my sound off here. It's going to be ding, ding, dinging. Okay. All right, how are we with tangent? We good? All right. All right, so I just want to make sure that this was in the forefront of your mind before we move on. So go ahead and flip this over, and this is going on page 78. 1 second, scroll. There we go. This is going on page 78. There's not a place to put it, but. And I have this one made up this way because I want you to see before we put anything in there, with the exception of the quadrantals, my ordered pairs, which give me sine and cosine, every single one of them is over 2. Okay, so unless it's a quadrantal and you're giving me a positive or -1 or a 0, it's something over 2. It's either 1/2, square root of 3/2, or square root of 2/2. Those are my only options. If I got something over 3, that's tangent. Okay, so let's start by talking about the quadrantals. I have the angles in here in degrees. Remember, if you don't know the radians for 225 degrees off the top of your head, that is fine. Nobody's going to ask you to do that. If you have to know the conversion, it'll be a conversion type question. So they're just on there, but we really don't care, okay? All right, so this is 0 degrees. It's also 0 radians, and then 2 pi, right? So we'll put 0 and 2 pi. What is 90 in radians? Pi over what? 2, good. What is 180? Pi. I literally just said it's okay if you don't know them, but then at the same time when you're talking quadrantals, I'm just pointing. So 270, what's that in radians? So remember, this is pi halves. This is basically 2 pi halves, right? So this is 3 pi halves. And then 4 pi halves, which is 2 pi, right? So let's go ahead and put the ordered pairs in for our quadrantals. What is it here at 0? 1, 0. Then up here at pi halves, 0, 1. Pi, -1, 0. And then 3 pi halves is 0, -1. Now, those really are kind of the easiest. I mean, I guess that's a matter of opinion, but they're also really easy to get mixed up. So make sure you think for a second before you say it wrong, because I know you know how to do it, but again, it's easy to get the 1 and the 0 mixed up. We good so far? All right, so then let's talk about 30 degrees. Now, I do think you need to know 60, 45, and 30 with the radians, just because I think it helps you place the angles. But what's 30 in radians? Pi 6. Okay. Pi 6. So let's do our pi 6 angles. What is your second quadrant pi 6 angle? Remember, if we're here, this is 6 pi 6, right? So we back up 1. What does that give me? 5 pi 6. So then what's your third quadrant pi 6 angle? 7 pi 6, yes. Then what do we think about your fourth quadrant? 11 pi 6, very good. Everybody good with those? Okay, what is 45 in radians? Pi what? Fourths, good. So what is your second quadrant pi fourths angle? 3 pi fourths, very good. And your third quadrant? 5 pi fourths, yes. Remember, in second quadrant, numerator is 1 less than the denominator. Third quadrant is 1 more. All right, so then what about fourth quadrant? 7 pi fourths, yes. Everybody good with all that? All right, so then what is 60 in radians? Pi thirds, good. What is my second quadrant pi thirds angle? 2 pi thirds, very good. Third quadrant would be 4 pi thirds. Fourth quadrant would be 5 pi thirds. Okay, so what's going to happen is the way we really need to use this is kind of going in the opposite direction. Instead of me asking you what is your third quadrant pi thirds angle, I would ask you what quadrant is 4 pi thirds in, right? So it's kind of the opposite. So as long as you know how to place them and figure them out, we should be fine. Okay, so for pi sixths, what is my ordered pair? What's the x value? Square root of 3 over 2. Remember, here's your hand trick. Here's pi 6, square root of 3 over 2, and 1/2, right? So then I know my second quadrant pi 6 angle is going to be square root of 3 over 2 and 1/2. But which one of these is negative? The x, good. Then 7 pi 6, that's also square root of 3 over 2 and 1/2, but which one's negative? Both. Then 11 pi 6 is also square root of 3 over 2 and 1/2. Which one's negative? The y, right? Okay, remember that we're just repeating the same things over and over again. All right, so you go ahead and get your other ordered pairs written in there. I bet you can do it without me. Okay, so what we don't want to have to do, I know some of you are still writing, and that's fine, but I don't want to have to write out this entire circle every time I need something, right? Because even though I've been asking you for like all of the first quadrant, all this stuff together, really what we need all this for and what we're learning this for is so that we can figure out what the sine of 5 pi 6 is quickly and whatever, so that we can use it in what we're doing. And that's kind of what I'm guiding you towards right now. And even when we're thinking about like, okay, my x is negative or my y is negative, that type of thing, that's fine because we understand the coordinate plane. But remember, not too long ago, I showed you, well, I have no idea how long ago it was. Time is just so weird now because we've had weird days. But in the first quadrant, everything is positive, right? A for all. Do y'all remember the little saying that goes around here? All what? All students take calculus. Remember that? That means that in the first quadrant, everything's positive. In the second quadrant, sine is positive, so cosine and tangent are negative. Third quadrant, tangent's positive. Fourth quadrant, cosine's positive. And it's not only those, but also their reciprocals, which we talked about a tiny bit. Okay, you know how we kind of talked about everything. Then we really focused on the first quadrant. Now we're going to focus on the whole circle. And then once we've got that down, then we'll add in more of the reciprocals, but we don't want to forget that they exist. Okay, so let's scroll down here to the bottom. I guess you're not really scrolling. I'm going to rewrite what we just did. All students take calculus. Like that little thing might be helpful at the top of your paper, depending on what you're working on, or have it in your brain, whatever. But what we're filling in here is the positive trig values. So in quadrant 1, they're all positive. In quadrant 2, from this right here, it is sine of theta, and its reciprocal. My choices are secant, cosecant, and cotangent. What's the reciprocal of sine? Cosecant. Good. Cosecant. Got to have that co in there. Quadrant 3, we know here that tangent is positive. And what is tangent's reciprocal? Cotangent. Good. Quadrant 4, we know it's cosine. And its reciprocal, which is just secant. Remember, there's one co in each pair. Okay, so sine goes with cosecant, secant goes with cosine. We all good with that? All right, so then our trig values. Now we know that when we're using the unit circle, sine of theta, is it x or y? Sine, y. And cosine is the x value. And that's true for a unit circle. We're going to write this out for any circle, meaning maybe the radius is not 1. So sine is actually y over r. Cosine is actually x over r, but remember we just end up with y and x because the radius is 1. And tangent is tangent y over x or x over y? Y over x. It's like slope. Yeah, y over x. So then our reciprocals, cosecant would be r over y, secant would be r over x, and cotangent would be x over y. So just a little reminder of that. We'll kind of write some of that stuff over and over again as we go through things. But are we good? Okay. So grab your other sheet of paper. And this is going to go on page 79 when we're done. We're going to start by reviewing reference angles. Okay. So the first day when we did reference angles, I had just reminded you what a radian was, told you that we're going to do everything in radians and no more degrees, and your little brains were probably like, what? And I was trying to make you figure out quadrants before you really understood them. So we're revisiting them now that we understand that a little bit better, and I think it will make it probably a little bit more sense to you. All right, so remember, if I have my angle theta, so here is theta, right? Then using my terminal side and the shortest way back to the x-axis, that's where we get our reference angle from. And we usually call the reference angle alpha, which looks like your squished Jesus fish, right? So we just do our best to make it look like alpha and not just a plain old A. All right, so let's plot 2/3, or let's graph it. So 2 pi thirds, what quadrant would that be in? Second quadrant, good. So here's my initial side. This would be my terminal side. So here is theta. and that is 2 pi thirds. Okay. My reference angle, shortest way back to the x-axis, and this would be alpha. And what would alpha have to be? It's pi thirds, because that would give me to that 3 pi thirds. Remember, with degrees, we had to actually do subtraction and add and subtract from 180 and 360. With radians and our special angles, not necessarily every angle, but our special angles, if it's a pi thirds angle, my reference angle is pi thirds. Okay, it's that easy. And remember, your reference angles are always positive, always acute. Okay, so it doesn't matter which direction you're going because they're not in standard position. All right, 11 pi sixths. What quadrant would that be in? Which one? Fourth, right? Because all the way around would get me to 12 pi sixths, and then I got to back up one. So I'd be right about there. So there's theta, 11 pi sixths. So then what is alpha? Pi sixths, exactly. There's alpha, and it is pi sixths. Now, negative 5 pi fourths. Since it's negative, I'm going the other direction, right? So what quadrant do we think that's in? 2, because if I'm here and I'm going clockwise, this is 4 pi fourths, and I got to go one more. That would put me there in the second quadrant. Pi fourths is 45, so I should be right there in the middle. That is theta, which is negative 5 pi fourths. So then my reference angle, what is that going to be? Pi fourths, exactly. Okay. That's why if we really get our first quadrant down, those reference angles, they are all first quadrant angles. Okay. All right, 5 pi 6, what quadrant are we in? Second, very good. So we're here. Right there, theta is 5 pi 6. So then alpha is right here. Alpha equals what? Pi 6. 7 pi 4ths, what quadrant are we in? All right, 3 and 4, which one is it? If I'm here and I go all the way around, that's 8 pi 4ths, right? So then I'm going to back up one. 7 pi 4ths. Oh, 7 pi 6 would be in the third quadrant. So theta equals 7 pi 4ths. All right, so then what is my alpha? Pi 4ths. So we can easily and quickly figure out our reference angles even without graphing them. We need to be able to graph them and understand that too, but it's not like I have to graph it to figure it out. All right, negative 7 pi thirds. Think about that one for a second. We're going to be thinking fractionally, right? And we're going to go clockwise. So if I go from here clockwise, that is 3 pi thirds, right? All the way to here, this is 6 pi thirds. Then I got to go one more to 7 pi thirds. I actually end up in the fourth quadrant there, okay? And then I got to show that I looped around like that, right? So there's my theta, and it is negative 7 pi thirds. What is alpha going to be? Pi thirds, exactly. Okay. Everybody okay with those? Any questions? You good? Do you have a question? Okay. Okay, got it. All right, got it. Okay. Now, as we go through these next examples, I'm going to have you write stuff down that you don't necessarily have to write down every time you do it, but they are the thoughts that are going to go through your head, but I want them on your notes so that if you go back to use those, you can remember what we were thinking through, okay? So let's look at this right here. And don't forget that all students take calculus, right? So if I want the sine of 2 pi thirds, like sine of pi thirds, you should be able to give me pretty quickly. Sine of 2 pi thirds, you should also be able to give me pretty quickly, but it should take you another couple seconds because you've got a couple things we got to think through. Your first thing you ask yourself is, what quadrant is 2 pi thirds in? What is it in? Second. Okay, so we're in the second quadrant. The next thing you ask yourself is sine positive or negative in the second quadrant? What is it? Positive. So then that's all I need the 2 pi thirds for. My reference angle is pi thirds. That's the one I've really got down. So what is the sine of pi thirds? There's your pi thirds. You can use your hand. Square root of 3 over 2. And it's positive because of this, so my answer is just square root of 3 over 2. And that's it. So we can do the whole circle. You just got to think about what quadrant you're in, and is my answer positive or negative? That's all we're looking at. So then we move on to cosine of 5 pi fourths. What quadrant is 5 pi fourths in? The third. Okay, so then in the third quadrant, is cosine positive or negative? It is negative. Okay, so then I know my answer is negative. Then I ask myself, what is the cosine of pi fourths? What is it? Square root of 2 over 2. So my actual answer is negative square root of 2 over 2. Okay? So that's why I've been saying if you can do the first quadrant, you can do the rest. You just got to know where these angles fall. All right, tangent of 11 pi 6. What quadrant is that angle in? In the fourth. In the fourth quadrant, is tangent positive or negative? Negative, because cosine's the positive one, right? So I know my answer is negative something. What's the tangent of pi sixths? Square root of 3 over 3. Good, because it takes 2 3s to get that 6. We all good? Yes? All right, so then negative 2 pi thirds. What quadrant is that in? The third, because the negative 2 pi thirds would go right here, would be in the third quadrant. In the third quadrant, is sine positive or negative? Negative. Okay, so my answer is a negative something. And then what is sine of pi thirds? Pi thirds, square root of 3 over 2. Okay, we good with that? See how that works? Alrighty, so my quadrantal angles, that's just there to remind you that we have what the quadrantal angles are, right? Because we'll talk about those again in a second. It's just like a little reminder there. So flip this over then. And another reminder that a unit circle is a circle with a radius of 1 unit. So we wrote this stuff down on the other piece of paper for any circle. We're going to rewrite it here specifically for a unit circle. So we know that sine is y over r, but r is 1, so sine is just the y value. Cosine is the x value. Tangent is what over what? Y over x. So then cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. And then another reminder that you can write your ordered pairs as cosine theta, sine theta when we are in a unit circle. Everybody okay with those? So then it goes on to say, I probably could have actually taken this section out, but it's fine because it uses the word map in it. The unit circle is frequently used to map, like we're mapping, we're taking this, we're relating it to the angle related to an ordered pair. So to map pi sixths, pi fourths, pi thirds, and their multiples, as well as 0, pi halves, pi, and 3 pi halves, which are your quadrantal angles. And then we're going to go through these like we did on the front. And I'm going to We're going to do some of them together, and then I'm going to call on y'all to help me work through some of them. All right. So we're going to state the quadrant of the angle, then find this. So basically exactly what we did. So 3 pi fourths. What quadrant is 3 pi fourths in? Second. And in the second quadrant is sign positive or negative? Positive. Okay. So then I just need the sign of pi fourths, which is what? Square root of 2 over 2. Very good. Then the cosine of pi, what quadrant is pi in? It's not, right? It's a quadrantal, so we'll just put a Q. We don't have to put the whole word. But when you think, okay, it's not a quadrant, it's a quadrantal, then the next thing I want you to think about is what is that ordered pair? So when you're at pi on the circle, what is that ordered pair? Negative 1, 0. Okay, so you can kind of picture you're over here, right? And then is cosine x or y? X. So your cosine value is negative 1. Okay, we good on those? What quadrant is negative 5 pi thirds in? So if I'm here and I got to go clockwise, right? This, if I go all the way around, that's 6 pi thirds. So I back up 1. I'm in the first quadrant, right? And everything's positive in the first quadrant. So then all I need to worry about is what is the tangent of pi thirds? What is that? Square root of 3, right? Okay, so now as we're going through these, I didn't say this, and I think most of y'all are trying to get them out of your brain, but I don't want you looking at the little half sheet where we have it all written out, and I don't want you looking at, I want you to try and get it out of your brain. That's the only way we're going to get good at this stuff. So I'm going to call on you. I'm not going to give you time to work them out first. I don't want you or expect you to just give me the answer. I'm going to ask you the same things. What quadrant are we in? What is the sign? And I'm going to step you through it, so nobody's going to be freaked out about this, okay? My first volunteer is Arturo. Arturo, what quadrant is 2 pi thirds in? Second. Okay. And in the second quadrant is sign positive or negative? Positive. Good. Then all I need then is the sign of pi thirds, which is what? Beautiful. Square root of 3 over 2. Okay. We good? Thank you. All right. Alanya. 3 pi halves, what quadrant is that in? It's a quadrantal, okay. And then what is that ordered pair then at 3 pi halves? Because that means we're right here, right? So what would that ordered pair right there have to be? 0, negative 1. Good. So that if that is my ordered pair, what is the tangent of that then? Tangent is what over what? Y over x, right? So if I put negative 1 over 0, what does that give me? Exactly, undefined. You got it. Good job. All right. Hassiel's not here. Oh, I just did that. Stephanie, what quadrant is negative 5 pi 6 then? The first one? Okay, so if I'm here, right, I'm going to start here. It's negative, so I'm going to go this way, right? This gives me 6 pi 6. And then I got to back up 1, right? Does that actually put me in the third? Does that make sense? Okay. So I'm in the third quadrant. In the third quadrant is cosine positive or negative? Negative, good. So I know I'm going to have a negative something. What's the cosine of pi 6? You can use your hand. It's totally fine. Very good. Don't be ashamed to use your hand. I use it too. I've told y'all. And I think when sometimes people aren't, it's because they don't understand it. It's not because they don't necessarily need it. All right, good job. Thank you. Don't be afraid. It's all good. All right, Jolie, 3 pi fourths. What quadrant are we in? Second, good. In the second quadrant is cosine positive or negative? So remember, we have all students take calculus. So if sine is positive, that means cosine is negative. Okay, good. So I know it's a negative something, what's the cosine of pi fourths? Pi fourths, square root of 2. Good, square root of 2 over 2. Oh, goodness. Square root of 2 over 2. Very good, thank you. It's okay if we're not experts. We're practicing. I'll help you through it. Wait, let's not here. Josiah, 2 pi thirds. What quadrant are we in? Second. Okay, in the second quadrant, is tangent positive or negative? In the second quadrant, it's negative. All right. So I know I got a negative something. What's the tangent of pi thirds? Square root of 3. Just the square root of 3. 1, 3 for 1, 3. Okay. All right. Thank you. All right. Goodness. Vanessa's not here, right? All right. Monse, is she here? No? No, she's not here either. Dianara. All right. Pi halves. What quadrant are we in? Okay, it's the quadrantal. Good. So what's the ordered pair there? 0, 1. Very good. And so then what is the tangent? Tangent is what over what? Be 1 over 0. And what does that give you? Well, no, just 1 over 0. Like when I put y over x, I put 1 over 0. What's that value? Can you divide by 0? No. So that means this is undefined. Yes. Good job. All righty. 3 more here. Let's see who we got. Camden, is he here? Nope. Jaime, you're here. Negative pi fourths. What quadrant are we in? Okay, so if I'm here, I'm going negative, right? Pi fourths is just 45, so I'd end up right here. Does that make sense? So I'm actually in the fourth. Okay. In the fourth quadrant, is cosine positive or negative? Okay. So positive. And my answer is just going to be whatever the cosine of pi fourths is. What's that? Very good. Square root of 2 over 2. We got this. Good job. All right. Fernanda, 5 pi fourths. What quadrant are we in? 3. Okay. In the third quadrant, is tangent positive or negative? Positive. So then I just need the tangent of pi fourths, which is 1. Good job. Everybody okay with those? Stop me if you got a question. All right, Ellen, negative 5 pi 6. What quadrant are we in? 3. Okay, good. We're in quadrant 3. In quadrant 3, is sign positive or negative? Negative. And so my answer is a negative something. What's the sign of pi 6? 1/2. Very good. So my answer is negative 1/2. We good with that? Y'all see how to think through it? And the more you do it, the quicker you'll get at it too. It'll be fairly simple as you go through. Your assignment is in Delta Math. Remember, now somebody told me that they think they have fixed it, but I haven't had a chance to look. Sometimes on some of these, Delta Math as their example will tell you to take your radians, convert them to degrees, and then figure it out. No, no, no. I don't care if you know what the sine of 225 is, right? I want you to know what the sine of the radian part of that is. So don't worry about converting them. Hopefully they have fixed that part of it. But oh, the other thing is, I probably should have said real quick, but on the reference angles, if you're asked the question, like if we have, let's just say pi fourths is your angle, right? So theta equals pi fourths. Then if it's in the first quadrant, the angle and the reference angle are the same. It's its own reference angle, okay? Which is kind of weird. So you're not always asked the question like that, but if you were, that's what's happening there, okay? Questions? Are we good? All right.